All right. So. This is the stuff that I'm working on here. Absolute value functions, reciprocal functions, lesson 4. You're looking for lesson 3, not in the course. Don't worry about it. I'll tell you that in class as well. An absolute value transformation transforms the graph of f(x) into absolute value of f of x. It's just one of the transformations that we're going to learn. In this course, we learn about the absolute value transformation. We also learn about the reciprocal transformation. And then in 30-1, you learn about, oh, goodness gracious. You learn about radical transformations. Why they split them up and didn't keep them all in one part of the course. Nobody asked me. But I think it would have been better. So we're going to see how to transform a graph into an absolute value part of the graph. So here we have a graph, and then we have absolute value graph. The function we're going to deal with is this. So let's make a little table of values. If it's y equals absolute, or if I was doing just y equals f of x, it's just going to be this. So I'm just going to put in -4. -4 minus 1 is -5. -3 minus 1 is -4. -3, -2, -1, 0, 1, 2, 3. Hopefully all that makes sense. Now what I'm going to do is I'm going to do the equation for this. This is going to be y equals absolute value of x minus 1. I take the whole f of x, and I just put that thing into the absolute value brackets. So all the absolute value does is, again, make it positive. So -4 minus 1 is -5. -1 becomes, or -5 becomes +5. -4 or let's try this again. My brain is going faster than my mouth. -3 minus 1, that's -4. -4 absolute value is +4. All you can see is that to get from here to here, all I need to do is absolute value it, so it just becomes positive. So -3, 3. -2, 2. -1, 1. 0, 0. 1 stays positive. So 1, 2, 3. So there's that. So if this is the original graph, -1 and slope of 1, so it's going to look something like that, assuming I can draw a straight line. Big assumption. What's going to happen here is that this one's going to do boop, boop. There we go. So when f of x is greater than 0, when the y value is positive, they are the same. And this is same to the graph. Identical, I think, is the word we're looking for here. When f of x is less than 0, then this is, as we already saw, a vertical reflection across the x-axis. Across x-axis. Okay? And what we already saw was that a vertical reflection across the x-axis is when you just multiply it by an a value of -1. Like it? Yes, yes, good. Sorry, I'm getting punch drunk over here. Okay, so here I have this. There's my y equals x squared minus 4. If I wanted to write y equals absolute value of x squared minus 4, that would be the equation rather than function notation. We graphing calculator this. It's a different one. Minus 4. Clear this out down here. Graph it. Oh, there it is. And again, all that would happen is this part down here flips up. So this was like -4, it's going to become +4. -5, +5. So it's just going to do that. So my final graph, when I draw the whole thing, is going to come on this part down to here, flip up, and then back up here. So that's what the absolute value works. So again, in this part, it's the same as the original graph. Also here, actually, coloring on it like that. Let's use the highlighter. Maybe it'll work. Let's see. So in this part, it comes down like that, and then up there. In this middle part, it's a reflection. So in the outside bits, it's the same, but in the middle part, it's a reflection. So that part just comes up. So yes, it works. The same thing we thought we saw in that last part works here. Okay, so when f of x is greater than 0, when the y values are greater than 0, when it's above the y-axis, then above the x-axis, I should say, then the graph is the same, but when not, it's a vertical reflection along the x-axis. So now I can give you any random graph and say, hey, random graph, let's draw you as an absolute value. So the part that's already above the axis stays the same. Anything below the axis flips up. So this part is going to come boop, and then to the side there, right? Because all of these points would just flip up. If I was drawing this, all of it's below, so all of it reflects. Again, when it says sketch, that just means approximately the right shape. If it said plot, that means accurately points need to be represented effectively. All right, so consider all the graphs from f of x, y equals f of x from parts 1, 2, and 3. Compare the graphs. Okay, domain, always the same. Actually, let's do this like a table. So f of x and absolute value of f of x. Okay, the domain is the same. The range is different. The range here, well, I can't even say that. Yeah, let's just say this. Not same. X-intercept, same. Y-intercept might be the same. But x-intercepts are definitively the same, and the domain is definitively the same. That's the part where I think they want us to go with that. Wow, is that really just the assignment already? That's the end of the lesson? Okay. Oh, I don't even know. We didn't talk about invariant points, which I think we ought to. The idea here is that the x-intercepts are invariant points. They're the places where the original and its absolute value are identical to each other. Technically, there are more than just the x-intercepts, but that's okay. So, yeah, you guys got this. If you need help, come on in. Other than that, practice, practice, practice.